Hi guys, hope you all are well. Welcome to my channel Sutapa's Biology. I am Sutapa Datta. Starting the rest part of the enzyme. In my last videos, I have told you about different structure of the enzyme, classification, mechanism of action, and ultimately the inhibition. But in enzyme inhibition, I have mentioned that the allosterism is also there because it's also known as feedback inhibition. Now, what is allosterism? What is allosterism? If we want to know, then we have to know what is allosteric enzyme. Allosteric enzyme is a specific type of enzyme. In other videos, we have observed that structure of the enzyme, it has only one active site. Okay, so जो normal enzymes है उसमें हम लोग एक ही active site देखे हैं, but in case of allosteric enzyme, they have two sites. One is active site and another is regulatory site or allosteric site. Now, their structure will be like this, not like the other enzymes. ये थोड़ा दूसरा टाइप का है. To some extent similar with the structure of skull, human skull. This is the allosteric enzyme, which has one active site. This is the active site like the other enzyme. And this is the allosteric site or regulatory site. Now, active site, you know, first the active site में substrate attached होते हैं. So, active site is specifically for the substrate. ये substrate के लिए specific है and the substrate should be of this structure. So, it can fit with the active site. So, this is the substrate here and this is the regulatory site. In regulatory site, when any inhibitor or inducer will attach, then it will modify the structure of the active site. तब क्या है? Active site का जो structure है वो flexible है and वो induced by the inducer or inhibitor. Inducer will modify it in such a manner that it can react and inhibitor will inhibit the reaction. So that's why the inhibition of the allosterism is known as feedback inhibition. Now, why feedback? What is feedback? Feedback, what is the feedback? You know, I think that suppose I am taking your class and what's your opinion about my class? That's the feedback of me. And I am teaching you. If parents ask or teachers of your school ask me that what's their feedback, that means how they're learning the thing, and that's the feedback of you. So after any interaction we can get the feedback from both the sides. Okay, so here also the when the product of the enzyme action will control the reaction of the enzyme, then that's known as feedback, and that inhibition is known as feedback inhibition. Okay, so now giving you the types of this. So allosteric modulation or allosterism can be of two kinds. One is positive allosterism and another is negative allosterism. Okay, so positive allosterism. What is positive allosterism? So allosterism have two kinds: positive and negative. And what is positive allosterism and what is negative allosterism? In first, I am giving the example of the positive one. Suppose there is an inducer which will attach with this. This is the inducer. With the attachment of the inducer, the active site will be active. Like that, active site can bind the substrate. It can bind the substrate in this way. So, this is the positive allosterism. If this happens, then reaction will go on. With the effect of the inducer, the reaction will go on. Okay? And in case of the negative allosterism, the structure of the suppose the tryptophan formation is taking place when the concentration of the tryptophan will be more in the cell, which might affect the cell or make the toxicity in the cell, then tryptophan itself will off the switch of the enzyme action, and this is known as the negative allosterism or feedback inhibition. How it will act? This is the inhibitor. The red one was inducer and the blue one is the inhibitor. And this inhibitor is the product of the enzyme. Product of the enzyme action. So this is the inhibitor or product of the enzyme action. Product of the enzyme action, as for example tryptophan. Now it will affect the active site in this manner. The active site will be distorted in this way. So this is the distorted active site. Active site where substrate can't bind. Is it possible for the substrate to bind in this way, in this structure? The substrate is not able to bind and it will just wait here. So naturally the enzyme action will be come to a halt. So this is known as negative inhibition and there will be no enzyme action. It will switch off the enzyme action, so there will be no reaction of the enzyme. So this is about the allosterism. Okay. So next we are coming to the topic relation between enzyme and the substrate. Relation of the enzyme and substrate can be graphically represented there is a curve or graph which can represent the relation between substrate and enzyme. Relation between enzyme substrate. If we plot a graph, velocity of enzyme this indicate the y-axis indicate that the velocity of enzyme action, and this one x-axis indicates that the concentration of the enzyme. There is a relation in between these two. Relation is like that. Suppose there is a curve in this manner. It's going upwards. This is the maximum velocity of the enzyme. Suppose if this is the maximum velocity, then it will be indicated as Vmax. So this is the maximum velocity of enzyme. And this is the concentration. So when this velocity is just half, that is half of this. If this is the maximum, then this is half, and this will be indicated as Vmax by 2. In Vmax by 2, the concentration of the enzyme is this. The concentration of the enzyme will be like this. This is the concentration, and this is indicated as Km. What is Km? Km means Michaelis Menten constant. So we can deduce from here, इससे हम लोग बोल सकते हैं कि Vmax by 2 equals to Km. So जब enzyme का velocity maximum से half होगा, that will be indicated as the Vmax by 2, and at that time substrate का जो concentration है, that is known as Km, and that remain constant for an enzyme always. Okay. So what's the relation of Km with the enzyme affinity? So the affinity of the enzyme is inversely proportionate with the Km, value of the Km. Like this, the value of Km inversely proportional with the affinity of enzyme. Affinity to whom? Affinity to the substrate. So we can say if the value of Km is less, then the enzyme will take more substrate. Okay, and if the value of the Km is more, then enzyme will not take more substrate, as it will indicate indicate that saturation is very near. It's just near to saturation point. Okay, so this is about the allosterism and enzyme substrate relationship, and this is the last video of enzyme. And if you have any queries, any problem, again I am telling you, completely observe the video, and then if you have any problem, अगर कोई भी query है, कोई भी doubt है, तो please comment box में लिखिए और हम उसको solve कर देंगे. Thank you.